On December 15, 2011, NASA's Solar Dynamics Observatory captured this footage of Comet Lovejoy approaching the Sun. An hour later, it watched as Lovejoy came around the far side of the Sun and began its long trip back to the outer reaches of the solar system. Other NASA spacecraft, such as SOHO and Stereo, also saw Lovejoy's close encounter. Lovejoy marked one of the few times that orbiting telescopes have been able to watch a so-called sun-grazing comet survive its trip around the Sun. Most are not so lucky. Besides being interesting to watch, the images and data collected by NASA's solar observing fleet can also help scientists learn more about the Sun itself. One of the biggest features that comets help reveal is the Sun's magnetic field. Since magnetic fields are invisible, we can only observe them indirectly, like using iron filings over a bar magnet. On the Sun, astronomers can look at where hot plasma in the Sun's atmosphere is trapped by fields to see their complicated loop structure. But farther away from the Sun, where the plasma is less dense, this approach doesn't work. Comet tails, with their ionized gases, are affected by magnetic fields, and so they can act as brief tracers. On April 20, 2007, Comet Encke had its tail stripped off abruptly by a coronal mass ejection that carried a strong parcel of magnetic field through the solar system. Even closer to the Sun, astronomers were astounded to see Comet Lovejoy's tail glowing in extreme ultraviolet light as it approached the Sun. They now think the glow is caused by energetic electrons in the Sun's corona interacting with oxygen from the comet. The glowing tail followed and illuminated some of the Sun's magnetic field lines. Careful analysis of the frames allows scientists to reconstruct where the field lines were, and even, to some degree, how strong they were. These comet tracers also illuminate small structures in the Sun's upper atmosphere, where they are usually too faint to be visible. Continued observation of sun-grazing comets will also help astronomers understand how hot material in the Sun's corona cools, and where that energy goes. Finally, long-term observations of sun-grazing comets will help us learn more about the solar wind. Some of the particles in the corona are traveling fast enough to escape and travel through the solar system. They begin moving at roughly 250,000 miles an hour, but start accelerating when they reach around 1 million miles from the Sun's surface. By 5 million miles out, they are traveling at up to 1 million miles per hour. The exact mechanism for this acceleration is not known. Comet tails that are blown off by the Sun travel with the solar wind and can act like a dye tracer in a river. Because they are made of different materials than the usual solar wind, they are distinct and easy to pick out, so they can show exactly how the acceleration unfolds. Because we are in a period of high sun-grazing comet activity, scientists can expect many more chances to watch these natural research satellites in the coming years. In fact, another large comet is expected to have a close solar pass on November 28, 2013. This comet is roughly the size of Hale-Bopp, so it should give quite a show. It will also undoubtedly be a treasure trove of information for scientists, and who knows what new solar secret it might unlock.